Hello dear participants, I welcome you all again here in this certificate course. Today we are starting our lecture number 35 and the title of today's lecture is Regression. So the objectives of lecture number 35 are as follows. The first objective is to make you all familiar with the concept regression, regression equation or regression model. Regression equation and regression model are the same things. Second objective of today's lecture is to make you all familiar with the procedure to compute or to obtain simple linear regression equation or model using MS Excel and SPSS. And the last objective of today's lecture is to make you familiar with the reading and interpretation of those models. So let me start this lecture introducing you the meaning of dependent and independent variable. See, the dependent and independent variable, these two different types of the variables, they play a very crucial role in the regression model or the regression equation. And if you all remember that in the week number 1, in a particular lecture, we already have seen that there are different types of the variables and we tried to understand the meaning of those different types of the variables. The present slide been taken from the same lecture from week 1 where we already have discussed the meaning of dependent and independent variable. But here in this lecture, before going to the regression part, we need to again revise the meaning of dependent and independent variable. So let me first explain you what is the dependent variable. The dependent variable is a variable whose values actually they depends on the values of another variable. Suppose I am having a particular variable, say that production of crops, and I'm having different values here enlisted here. These values actually they depends on the values associated with the another variable. In that case we call this variable is a dependent variable. Fine. Then what is the meaning of independent variable? Independent variable, these are the variables whose values are actually stand alone values. They don't depend on the other variable values. Fine. In actually these values actually affects the values of another variable, so they are known as an independent variable. So these two variables are going to play a very crucial role here in the regression equation. Now once we understand the meaning of dependent and independent variable, now let me take you to the meaning of regression. See, the regression is a concept. This is just a terminology. In regression, actually we compute or we obtain regression model or the regression equation. A regression model and regression equation, they are same. They are like synonyms. Fine. So what actually we do here in the regression? In the regression, when we compute the model or when we compute the equation, that model or equation, it gives us mathematical relationship between dependent and independent variables. So in the previous slide we already have seen that what is the dependent variable and what is independent variable. Suppose we are having plenty of variables, then we first determine a particular variable is a dependent variable and a particular variable is independent variable, and then we obtain or we compute a particular model, using which model we are going to predict the values of a dependent variable for the specific value of say that independent variable. How it works, that we are going to discuss in today's lecture. Fine. What are the prerequisites here in the regression? The first prerequisite is that there should be a strength of relationship between two or more variables. Suppose we are having different variables like x, y, z and many more. There should be some strength of relationship. And how to find the strength of relationship? If you all remember in the previous lectures, we already have seen that how to compute correlation. If we are getting a very high correlation, then we can say that yes, there is a kind of a high positive correlation in that particular two variables or more than two variables. If we find such kind of strength of relationship between two or more variables, then we can go for the regression part. Second prerequisite is that we need to determine the dependent variable and independent variable. For simplicity here, onward this slide we are denoting dependent variable by capital Y and we are denoting independent variable by X. Fine. So from the data, once we collected our data, then we need to determine which particular variable is dependent and which particular variable is independent for me. So how to determine this? It depends on your theoretical knowledge, your own understanding of your own research topic. Fine. So it depends on you that which variable you are going to determine as a dependent and which variable you are going to determine as a independent. It is kind of a skill that you require to determine these two different variables. So here, using these two different variables, we construct the regression model using some formula or software. And how does that regression model or equation looks like? Suppose if you are having only one dependent variable and one independent variable, then it will look like this: y is equal to a plus b x. If you go to the different books, you will find this equation in a different pattern. For example, in some books it is been given like alpha plus beta x. Fine. In some books y is equal to lambda plus say that beta x. There are different ways. For a simplicity, we are going to use only this a and b. Fine. A is intercept and b is a slope. What actually do they mean? That also we are going to discuss in the upcoming few slides. So let me take you to the further slide, that is regression model and regression equation. Let me talk little more on this part. So what is regression model or regression equation? So this is an algebraic expression of the regression line. Now what is regression line? If you all remember, we already have seen that how to construct the scatter plot, scatter diagram, right? If you plot the scatter plot, if you draw kind of scatter plot, from this scatter plot you can obtain a particular line. That line is known as a regression line. Fine. And that regression line gives the most probable values of a dependent variable y for the given values of independent variable x. Fine. How it works? That also we are going to discuss using one example in few upcoming slides, when we'll demonstrate that how can we construct the regression model and how to use a scatter plot to construct the model. That all that thing that we are going to discuss in few upcoming slides. Fine. So equation is expressed as y is equal to a plus bx, where y is a dependent variable, x is an independent variable, that we already know. So on the left hand side there is a dependent variable, it depends on the right side, and x is an independent variable. Fine. A and b, they are very important. What is a? A is a y intercept, the point at which the line crosses x axis. If I just stretch this line here, then this point, when my x is 0, then how much would be y? Actually there are different dimensions to this value. Fine. So we are not going to talk much on this a, but we are more interested in this b, because it represents the slope of line. Moreover, it represents the average change in y due to change in x by 1 unit. So what actually does that mean? That we'll see with one example. Fine. Now let me take you little further. So as we have mentioned here, that first we need to determine the dependent and independent variable, and it requires a very theoretical understanding of our own research topic, and then we can construct the regression equation computing a and b. So computing values of a and b is the important part. Fine. And that has been taken care by the softwares. Fine. And here in the linear regression, again in the regression there are two different parts: linear regression, non-linear regression. In a very preliminary stage, we'll be talking on the linear regression only. Fine. What is the linear regression? In linear regression, the value of dependent variable y changes at a constant rate. So constant rate is very important. Fine. The values of y changes at a constant rate as a unit change in independent variable x. Now let me take you further and to explain you that there are two different types or the two different classifications of the regression equation. First is a simple linear regression equation or simple regression equation, and the other is a multiple regression equation. What is the difference between these two? In this, we are going to use only one independent variable, that is say that x. And in the multiple regression equation, as mentioned here in the name multiple, there are multiple independent variables. As we all know that on the right hand side there are independent variables with their coefficients. What are the coefficients? All the b are the coefficients. So b1 is a coefficient of x1, b2 is a coefficient of x2, b3 is a coefficient of x3. Fine. And what we are going to compute? We are going to compute this b, the a, b1, b2, b3 and many more coefficients. We are going to will try to obtain coefficients. Fine. For the multiple regression equation, on the left hand side in a simple regression equation, here also we are going to compute these coefficients a and b. Now in today's lecture, we'll demonstrate you simple linear regression equation, and in the next lecture, we'll demonstrate you multiple regression equation with an example. So let me start here with the simple linear regression equation. What is the procedure here in the MS Excel? In MS Excel, we have taken the same data from the previous lecture where we already have seen that how to compute correlation. Fine. So here we are having the two variables, height and weight, and the first prerequisite as mentioned earlier, that we need to find that if there is a strength of relationship, then only we can go forward. Now so that I have computed correlation and I found that yes, there is a high positive correlation. Fine, 0.85. So I'll go further. Now the second prerequisite is that we need to determine the dependent variable and independent variable. Who depends on whom? Now here we are having two variables, height and weight. And if I look carefully, my height depends on weight. At the same time, my weight also depends on height. So how to decide? How to determine? It completely depends on your logical understanding and your objectives of your research topic and your theoretical knowledge. So far this data is concerned, here as a researcher we are going to consider here weight as a dependent variable. So weight is a dependent variable and height is independent variable. You can go vice versa, no problem. Fine. For the sake of understanding, we are just going with this pattern. So here my weight is on the left side. Fine. This is dependent variable, and on the right hand side my independent variable is height. So my weight depends on height. Now I am going to compute these coefficient a and b, and this b value tells me, this b value, the value which I'll compute, which I'll get here for the b, this value tells me that if my height increases by 1 centimeter, then my weight will increase by how much kg or particular that unit. So that we are going to explain using this regression model. Now let me go ahead. How to construct this regression model? For that I need to go to data. I'll click on data, then I'll go to data analysis. Now I'll click on data analysis. A new dialog box pop-up window comes. Now here in this data analysis, simply I'll go to the regression. I'll click on this, then I'll click on OK. As I press on OK, a new pop-up window comes. Now here you should be very careful. Here is input y range and input x range, and if you all remember, y is equal to a plus bx. So you need to know that what is your x and what is your y, what is your x and what is your y, that it should be clear with you. When we are selecting data here for this y range, we are going to select this weight data, and for this X range we are going to select the height data. Fine. And here you should be very careful. Now simply I'll go here, I'll click on this and I'll select the weight data. Then I'll go to the input X range, I'll click on this and then I'll just select the all the numbers values here from the height data. Then I'll go to the output range, I'll click on this, I'll select any cell where I just need to have my output. Then I'll click on OK. As I press on OK, I've got three different tables. In the first table, some sort of regression statistics is there. In second table, there is ANOVA, but we are more interested in this part, coefficient, intercept and coefficients. Fine. And if I go further and if I construct my model, y is equal to a plus bx, y is weight is equal to this intercept is nothing but a is intercept, that is minus 96.53. So it is mentioned here. And x variable 1 coefficient, this is your b is equal to 0.99. So that is plus 0.99 height. Now what is the meaning of this model? What is the meaning of this model? Now let me go ahead. So here, for each increase of 1 unit of x, increase of 1 unit of x, the predicted value of y is estimated to be increased by 0.99. So this is the value by which y will increase if the x increase by 1 unit. So in terms of y and x we can explain like this. But if I go further and if I explain in terms of weight and height, then how can I explain this? For each increase of 1 centimeter in height, why 1 centimeter? Because this height data here, it is in the centimeters. Fine. So we measured this variable in the centimeters, so that here for each increase of 1 centimeter in height, the predicted value of weight is to increase by 0.99 kg. 0.99 kg. Weight will increase by 0.99 kg. So this is the way that we interpret, this is the way that we read this model. And as I mentioned earlier, we are not going to talk much on this A, because that A is having different angles, different dimensions. In preliminary stage, we will focus on this B only, the slope of the model, or slope of that coefficient. Fine. Now let me go further and explain you that is there any shortcut method to obtain the regression equation? Answer is yes. In MS Excel, you are having the data. Simply go to the scatter diagram, go to insert, and in insert go to scatter diagram. Click on the scatter diagram and select on this scatter with only markers, the first one. Fine. First select both the variables, height and weight, because we are using the shortcut method. First we have selected the numbers, all the numbers, both the variables. Then I'll click on the scatter diagram. Simply I have got the scatter diagram. So this part already we all are familiar with, because this part we have seen in the previous lectures, week 1 and week 2 somewhere. Fine. Now simply click on this border and go to the chart layout. If I go to the chart layout, in chart layout there is one layout which gives us the regression equation along with the scatter diagram, and it is denoted here by fx, kind of that part is there. So I'll simply click on this. As I click on this, here along with this scatter diagram, I get the regression equation, and that regression equation is here. Only the difference is here my independent variable x with its coefficient, it comes first, and my intercept a, it comes later. So that is the only difference. So you have to rewrite this like say that minus 96.53 plus 0.99 x. So this is the way that we can go with the shortcut method here in the MS Excel. And if we look at the results using data analysis, that method and the shortcut method, we are going to get the same result. Fine. Now let me take you to the SPSS. How to obtain simple linear regression in the SPSS? For that, simply we need to first open our SPSS. Then simply I too need to go to file to import my particular worksheet. So I'll go to open, I'll click on data, then I'll go to the location where my worksheet is located. I'll select this, then I'll go to open, then again a new pop-up window comes here. Again simply I'll click on OK. Now my data is here. Now what is the first step? First step is always to go to variable views. So I'll click on the variable views and I'll define my variables. I'll cross check whether everything is fine here or not. Once I redefine all the things, then again I'll go back to the data view. Now my data is ready for the statistical treatment. Now here simply I'll go to the analyze, and in analyze I'll go to regression. In analyze I'll go to regression, and in regression I'll go to the linear part. So simply I'll click on linear, then new pop-up window come, new dialog box come, and here now we need to determine the dependent and independent variable. We are having plenty of variables here enlisted here, so we need to recognize our dependent variable. So for this data is concerned, our dependent variable is weight. So I'll place this weight here, and my independent variable is height. I'll place this height here in the independent that column. So let me click on weight. I'll put this in dependent variable. Let me put height, and let me put this in independent variable. Then simply I'll click on OK. If I go on these different parts, statistics, plots, there are different options. Fine. But simply if I click on OK, I'm going to get the model. So let me click here on the OK. As I click on OK, I get the result in the output window. And here are different tables. Here are different tables, like in first table, I'm getting the variables entered, removed. In second, model summary is there. In third, ANOVA is there. But we need to go to the last table. So I'll scroll it down. So I'll go little down. And here is the table titled with coefficient. I'll find here the coefficient values. Here is a constant. Constant is a synonym to the intersect. Fine. This represents me the A is equal to minus 96.53, and height of the respondent coefficient here is 0.991, that is B is equal to 0.99. The same thing I have mentioned here. Now if I go further and if I look at the results, in MS Excel I have got the same coefficient, and in SPSS I have got the same coefficient. There is no change in the result. So I hope you all understood that how we have constructed regression model, simple linear regression model using MS Excel and SPSS. In the next lecture, we'll try to understand that how can we construct regression model using more than two independent variables. So thank you, and see you soon in the next lecture. Thank you.